Let's take a look at some sample problems from section 4-6, and in our textbook we will begin on page 180, and we're looking at number 6. Number 6 says a social security number consists of 9 digits in a particular order, and repetition of digits is allowed. So order is important, repetitions are allowed. If randomly selecting digits for one social security number, what is the probability that you get the social security number of the president? Okay, so we have 9 digits, and for each one we have 10 choices. So the total number possible, 9 zeros here. Okay, so we have 1 billion. So the probability of getting the president's social security number would be 1 out of the 1 billion. Okay, and number 8, Harry Potter books. There are 7 books in the Harry Potter series. If the books are read in randomly selected order, what is the probability they are read in the order that they were written? So in this case, we're selecting all 7 of the books. Order is important. The factorial rule would apply since we're selecting all of them. So we have 7 factorial ways to select the books. And if we simplify that, that's 5,040. So the probability in the same order that they were written, if we just select them randomly, would be 1 out of 5,040. Okay, and number 10, we're playing blackjack. In the game of blackjack played with one deck, a player is initially dealt 2 different cards from the 52 different cards in the deck. Find the probability of getting a 2-card initial hand consisting of the ace of clubs and the ace of spades in any order. Okay, so as we think about that, on the first draw, we could get either one of the aces, so we have 2 out of 52. Then on the second draw, we can get, we're trying to get the remaining ace, and this time the number of cards is dropped down to 51. So I'm going to reduce this here, and we get 1 out of, let's see, I think that's, okay, 13, 26. So we have 2. We could get the ace of clubs or the ace of spades on the first draw. Then on the second draw, we have to get whichever one is left. So we're drawing from 52 cards on the first draw, only from 51 in the second draw. Okay, moving on to number 16, the Florida Lottery. Winning the jackpot in the Florida Lotto requires that you choose 6 different numbers from 1 to 53, and your numbers must match the same 6 numbers that were later drawn. The order of the selected numbers does not matter. If you buy 1 ticket, what is the probability of winning the jackpot? Okay, so with the lotto, repetitions are not allowed, and we're told order doesn't matter, so that means we have combinations, and we're told there are 53 numbers, 1 through 53, and we're choosing 6, so I need to figure out the number of combinations of 53 taken 6 at a time, and I'm using my calculator for these. I'm getting 22,957,480. So the probability of winning would be 1 over that. There's only one way to win. So not very likely that you'll win in that case. Okay, we're moving on to number 20. This is the Illinois lottery. In the Illinois Little Lotto game, you win the jackpot by selecting 5 whole numbers from 1 through 39 and getting the same 5 numbers in any order. So order doesn't matter, that are later drawn. What is the probability of winning the jackpot? So we're choosing 5 from 39. Order doesn't matter, no repetitions allowed. So combinations of 39 taken 5 at a time. So that gives us 575,757. Okay, so the probability of winning would be 1 over that. Okay, and that's part A. Let's look at part B. Part B asks, in the Illinois Pick 3 game, you win a bet by selecting 3 digits, and they're talking about 3 digits from 0 through 9, with repetition allowed and getting the same 3 digits in the same order. So because repetitions are allowed, that means we need to use the fundamental counting principle, and we have 10 choices for the first digit, 10 for the second, and 10 for the third. So there are 1,000 different possibilities here. And so the probability you win is 1 out of those 1,000. All right, now part C is a little bit different question from what we've had so far. It says the Illinois Pick 3 game, which is the last one we just talked about, returns $500 for a winning $1 ticket. What should be the return if Illinois were to run the game for no profit? So what I like to do is I look at the probability times the amount won. So if we look at the probability of winning times the $500 won, that gives us 1/2. 500 over 1,000 would be 1/2, and that's 1/2 a dollar, or thinking of it the way we normally think about money, $0.50. So we should be, if we're going to win $500, we should be paying 50 cents. We're paying $1 to play this particular game. So in order for it to come out to be $1 instead of 50 cents, this would need to be $1,000 for it to be really a fair game where they made no profit. So the answer is $1,000, and like I said, that's a little bit different question from what we've had. Okay, let's move to number 24. Safety with numbers. The author owns a safe in which he stores all of his great ideas for the next edition of this book. The safe combination consists of 4 numbers between 0 and 99. So we have 100 possible digits. And the safe is designed so the numbers can be repeated. So that means we need the fundamental counting principle. It's 4 digits, so it's 100 to the 4th power. If another author breaks in and tries to steal the ideas, what's the probability that he or she will get the correct combination on the first attempt? Assume that the numbers are randomly selected. Give the number of possibilities. Does it seem possible to try opening the safe by making random guesses for the combinations? Okay. So, as we look at this, this is going to be, let me not put the comma in yet, that's my big, 1, 2, 3, 4, 2, 3, 4. Okay, so I'm coming up with 100 million combinations. The Probability it'll open on the first try is 1 out of that 100 million. So are we concerned that feasible to try opening safe by making random guesses? No, too many possibilities. Okay, and so our last one is identity theft and credit cards, something that's in the news fairly often. Credit card numbers typically have 16 digits. And these digits are from 0 to 9. So we have 10 possibilities for each one. But not all of them are random. Answer the following questions and express possibilities as fractions. What is the probability of randomly generating 16 digits and getting your MasterCard number? Okay, so 10 to the 16th. Oh my goodness, that's a lot of zeros there. So the probability that it's mine actually would be 0 because I don't have a MasterCard, but saying that I did, get my commas in there. Three, 6, 9, 12, 15, 16 zeros. Wow, not very likely. Okay, part B. Receipts often show the last 4 digits of a credit card number. If those last 4 digits are known, what is the probability of randomly generating the other digits? Okay, so if I take away the 4 that are known, that would leave me 10 to the 12th, which would be a 1 followed by 12 zeros. 3 more, and 3 more. Okay. So this time the probability that it's mine would be 1 out of the Okay. C, Discover cards begin with the digits 6011. If you also know the last 4 digits of the Discover card, what is the probability of randomly generating the other ones? So we've removed 4 more, so that's going to be 10 to the 8th. So I need 8 zeros. So probability now would be 1 over 100 million. Is this something to worry about? No, it's still a large number.